Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the ACT Practice Exam 4. The link is provided below if you want to look at the problems before looking at this video. But that being stated, I'll be going over specifically numbers 4 through 6. Usually when I do these problems, I go over them real quick and explain in depth how I was able to do the question. But before I continue doing number 4, I must mention that the prior question number 3 had this scenario provided right here, which I'll be using to help me solve for number 4. So I'm going to go ahead and get started. So, okay, number 4, the angle of this is x. Okay, let's find this expression for b. Okay, so it's definitely not that. It will never make sense. Any of those will make sense. Okay, so for number 4, my final answer, and I'm going to move this up, is going to be I. And I'm going to resketch the chart a little bit, or at least try to guesstimate sort of what it will look like. It looks sort of like this. They provide you an angle of x right here, and they say this angle right here is beta, and they want an equation that represents this. So when I was doing this, thinking about this question, the things that I automatically knew was that sort of there's a property that exists where if you get an exterior angle outside of a triangle, usually or not, it plays into the whole idea of the 180 degrees minus, etc., whatever the angle would be and so on, because it plays upon the idea that if I create some sort of angle, let's say this was the angle right here, and I was to create a linear line, I could sort of recreate two different scenarios here actually. There's actually going to be an angle versus this part right here, so I might even use a different color just so you could see it clearly. So there's a relationship that's going on right here, but there's also a scenario where the exterior angle sort of, like the properties of it also plays out right here too. And so when we're working with this sort of exterior angle sort of thing that's going on from this triangle, I know F wouldn't make sense because these are not what we call vertical angles by any means. There's not two angles that are just crossing perfectly like an X, so that wouldn't make sense. 2X wouldn't make sense because there's no properties like that we learned in angles about triangles, and nor does H make sense because 90 degrees shouldn't be something relevant to triangles unless this is a right triangle, which is very clearly it is not the case. And so I knew right off I and J will be the only possible choices automatically because it has something to do with the 180. For me in the end, I knew right off 180 minus x would logically make most sense to this scenario. 180 minus x over 2, I can't think of any scenario where you divide this angle, exterior angle, by half, and I don't see anything that tells me or indicates that that's logically made sense, and thus why for number 4 I chose the answer I, and that concludes my explanation for number 4. Number 5 also continues on the same type of question on the scenario they provided, so I will be using that along the way while I'm solving this. So I'm going to go ahead and do number 5. So number 5. To look better, so under the angles and triangles right side, take the right angle at vertex A. Okay, vertex A. Okay. To lead the A and B, A, B. Yeah, let's do that. AB 4 and AC 5. Nearest point 1 foot. How long must it take to replace this 6-foot piece? Okay. 16 plus 25, 35, 41. So square root of 41. Okay. 4. Okay. So for number 5, my final answer is going to be D 6.4. For this specific question, I didn't really need the scenario as much. What happened was that they used that scenario where there was a normal like just a random triangle, a cute triangle or something of that sort, and they told me that in the end they rearranged the lumber or the flower bed parts so that it will create a right triangle as I drawn right here. Right, they're asking for this measurement. What's BC in the end? That's what the question is asking for. So I just simply did was use the concept called Pythagorean theorem. Pythagorean theorem, which only works for right triangles. And so Pythagorean theorem, the equation is a squared plus b squared equals to c squared, and I need to solve for c. That's my goal. So I labeled this as a, I just labeled this as b. This is going to be my c. And so, in the end, I just simply did was in mental math so that's why I didn't show it, was 4 squared plus 5 squared equals to c squared, so it'll be 16 plus 25 equals to c squared. It will end up being 41 equals to c squared, and then I have to square root both sides, which will end up being 6.4 equals to c, and thus how for number 5, I got my final answer as D. And that concludes my explanation for number 5. To continue on to number 6. So for number 6, expression says integer for all integers a and c. Okay. 1, 2, 2, 2, 3. This looks like it's going to be even. If I choose like 2, but if I choose 3, that's not going to work. Yeah, that's definitely not going to work. Neither these 3 for certain. 3 times 3 is 9. If I did 3 times like 2, that'd be 6. No. Yeah, but then if I choose like, yeah, I see the issue. Okay. Yeah, that for certain will beat it. Okay, so for number 6, my final answer is going to be F. And now I'm going to go ahead and explain to you how I was able to get to this answer. So for number 6, the important thing that I was looking for is the easiest way to do this is to test a few numbers for both A and C to see if the property, you could break the property. And so when I was doing F mentally, I sort of chose values like, for example, I chose like A equals to 1, and I made C equals to 2. Then I chose like A equals to 2, and then made C equals to like 3, just to test if I switch between even and odd, odd and even, and whatever not, and I wanted to see if something would occur. And so when I did this, both of them were going to be even numbers for both scenarios. When I tried to test it out on other ones, like for example this one, I got 3 times 1 is 3, but I got 3 times 2 is 6, 6 plus 3 is 9, so it didn't work. When I tried this one, 1 and then 2, the 2 plus 2 is 4, it works. So I tried 2 and 3, so it would be 4 plus 3, which is 7, which does not work. That's how I knew H wasn't going to work. I tried this one, it would be 4 plus 1 is 5. The first scenario makes me not make it work. 1 times 2 is 2, but 2 times 2 is 4, it works. And then if I tried 2 times 3 is 6, but I did 3 times 3 is 9, this is going to be odd, and that's how for number 6 is F. This is the fastest strategy. You do have to brute force some questions. Usually when you're working with variable-based questions like this type of question, it is the easiest to brute force it. Just compute very fast. You can mental math the basic, like multiplications in your head so that you could save time and not have to use the calculator. The big clue also for this question allowed me to note is that whenever you multiply with an even number, usually it's going to become an even number. So like if you think about 2 times 3, it will become even, or 2 times 4, it will still be even. And that's why I knew F most likely would be the case. And that concludes my explanation for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter so that we could continue to make content like this. I hope you have a wonderful day.